So let's check the memory of parents, how we can read them. First of all, as you know, main memory used for composite data such as array, a structure, or dynamic data. In order to apply any arithmetic operations, you should first load that value from the memory into the registers. And when you perform your operation, you should write back or store the result from the register to memory. In computer, each memory location can hold 1 byte, and each location has its own unique address. Let me draw something. So I assume that this is the memory. And you kind of saw 1 byte in each location. Each of the registers in MIPS can hold a 32-bit data. So when you want to store the content of one register into memory, you need 4 memory allocation. For this purpose, for example, assume that inside the register I have this number. Well, this is a 32-bit number. When I want to extort this number, I need 4 bytes. So which part or which byte should be stored first? This 00 or this 1 to each digit in the hex needs 4-bit. So this is 8-bit or 1 byte. This is another byte, the 3rd byte and the 4th byte. Which one should be stored in the first location? There are 2 ways. Speak Indian and Little Indian. It's depend on the architecture of the processor. For example, MIPS is a big Indian, so the most significant byte will be stored at least trace of a word. But another way, for example, in the x86 family, the processors are Little Indian, so this significant byte will be stored at least address. Let's check it here. Big here means the largest address in this example, 103 has the least significant byte. This significant byte is this 100. So 00 will be here. And 1, 2, or the most significant byte of this number will be a store in this 1, 3, 4. These are in the hexadecimal. I show it by putting H here. So this is 1, 2 in the hexadecimal, 3, 4 in the hexadecimal. Each one needs 1 byte. But if you want to extort this number for the x86, it will be completely reversed. First 00 will be here, then 11, then 34 will be here and 12 will be in the last location. So in order to install a vault, we need 4 bytes of the memory. Pay attention that the world should be aligned in the memory, so the others should be multiply 4. For example, like this 100 can be a start out of a word. We cannot start a word from this point 101 or 10 to 100. 104, 108 can be the start of this of the one word in their memory. Okay. Let's see how we can really load one data from the memory and put it inside a register. Check this code in the C language. G equal H plus array index 8. The content of the array with index 8 should be read and add with the variable H and store in G. As you know from the data structure, in order to find the authors of the one index of elements in the array, the compiler used the base address of the array and then that base will be add with the index multiplied by the size of the elements of the array in order to find the address of the index 8 of this array. Index 8 compiler use this formula. First is address of the A which is stored in by the compiler will be used and then it will be multiplied by size of the elements of the array. For example, if the character, then each element takes 1 byte. If the array type is integer, maybe 2 or 4 bytes is necessary for each of them, depends on the machine. So this is the formula to find the index 8, or in the general format array index. I will be computed by this formula. In the MIPS assembly, we have to perform it by our code. There isn't any index AI in the assembly. Let me show you. So assume that the variable g exists in $, as one variable h is inside the sign as to register, and the base address of the array is inside $as 3. When we compile this code, the corresponding MIPS code will be in this format. This is a new instruction load word, but it is used to read data from the memory. So this is the destination and it has only one parameter. This is the address of the data that we want to read from the memory. So let's see what is inside this part. 32 pointers. $sign is $3. Sign is 3 is the base address. So the base address is here and this is the offset. The offset is a constant number that can be added with the base authoris. It can be 0 or any other positive number or negative number. In fact, it is sign number. This number will be added with the base address and then the CPO reads the data from this address and put it inside T0. So a index 8. Since each element has 4 bytes, 8 times 4 is 32. This formula that I mentioned. Size of elements in this example is 4 bytes. 4 times the I is 8, 8 times 4 is 32. So this 32 will be added with the base addressed. Based out of the area is inside $3. So by this way, we read a index 8 and a story in register temporary 0. Now we perform this addition by another arithmetic instruction and store the result in $sign as 1. This $sign is 1 should be a store back into the corresponding variable g. There is another instruction is W for storing the data into the memory, and this is the only instruction that we have in order to read data from the memory load word. Take another example here. The destination is another relocation. A index should be filled by h plus at a index 8. So in order to read a index 8, we use this part. By load word. 8 times 4 is 32. And this is the base address. We read one element from the array. Then we add it with the edge and the result is here in T0. Now I want to restore this result into the corresponding location. As you can see, a store. This is the source and this is the destination. The content of this register will be stored in this address. 12 is the index multiplied by 4 is 48. So the offset is 48 and the base address is inside the sign as 3. These two numbers are together and give us the destination address, and the T0 will be stored in this location. So a store bought for writing in memory and load bought in order to read from the memory. And as you can see, for implementing array, you are responsible to find the corresponding entry address of the array and read that data and store it in one temporary register.